Hello everyone and welcome back to the class. In today's class we will discuss about the calculus. Calculus has two parts. First one is differentiation and second one is integration. Correct? And first of all, this calculus is introduced by the Newton and the Leibniz, everyone. So keep this thing in your mind. This calculus is introduced by the Leibniz and the Newton. And if we will see notation of the differentiation, it is dy by dx. And sign of integration is this, everyone. This sign is introduced by the Leibniz, not a Newton. Keep this thing also in your mind. So first of all, we will discuss about the differentiation, everyone. Let's see what is the definition of the differentiation. It measures the instantaneous rate of change one quantity with respect to another. So here we are measuring instantaneous rate of change one quantity with respect to another, everyone. So here we are finding rate of change, but we are measuring instantaneous rate of change, everyone. Now what is the meaning of this instantaneous? Instantaneous meaning is what? Interval is very small, everyone. Interval is very small. Correct? This is the meaning of instantaneous, or we can say that infinitesimal is small. Correct? So infinitesimal is small also, we can say that. So in the differentiation we are finding rate of change. Correct? But rate of change has two types, everyone. Average, and second one is, everyone, instantaneous. Correct? So average and instantaneous. So in the average, interval is long, everyone. Interval is long in average. And in the instantaneous, interval is very small. Already we know this thing. Or we can say that it is infinitesimal small. How we are writing average, everyone? How we are denoting average? With del x by del t. Here interval is large. Correct? And instantaneous, we are writing dx by dt. Alright, dx by dt. So if suppose 2 points are present at a very large distance, this we have 2 points A and B, and the separation between these 2 points is very large. It is del x, everyone. So separation between these 2 points is very large. Correct? So definitely, if you want to cover this distance, this separation, so large time is required here. Correct? So here interval is very large. That's why it is what? It is the average, everyone. And when 2 points are very close to each other, correct, separation between these 2 points is very small, or we can say that infinitesimal is small. So we will denote with the dx, everyone. So definitely, if the separation between 2 points is very small, so time required to cover this distance is also very small. Correct? It is very small. So in the average, interval is long, everyone. It is large, and in the instantaneous, it is infinitesimal small. I think this thing is clear to everyone. Correct? Mathematically, how we can write down, correct, this instantaneous? So we know that in the instantaneous, interval is very small. Correct? So here del t tend to 0. We are finding change in position with respect to time. So with respect to time, we are finding here position is a function of time. Correct? So del t tend to 0. The meaning is what? Here this interval of time is approaching to the 0, but it is not equal to the 0. Correct? So it can be written as limit del t tend to 0 del x by del t. Del x by del t is what? It is the average, everyone. So limit del t tend to del x by del t is equal to what? It is dx by dt. So when interval is very small, then average will convert into instantaneous, everyone. If these 2 points are present at very large distance, then it is the average, and when it is very close to each other, then it is the instantaneous, everyone. correct? So here we are finding rate of change or in position with respect to time in very small interval of time. That's why it is a differentiation, everyone. In the differentiation, interval is very small, correct? And in the average, this interval is large. So this is the difference between the average and instantaneous. And in the instantaneous, we are measuring rate of change in very small interval of time. So I hope right now this thing is clear. Let's see one example, everyone, then you will get more clarity. Let's suppose I want to measure change in length in my nail, everyone. So let's suppose change in length in my nail in 1 month is 1 centimeter. So here we can see it. Here interval of time is very large here, correct? This interval is very large. We are talking in 1 month. So that's why this interval is very large. So this is what? This is the average, everyone. Del L by del T. Change in length in nail in 1 month. So this is what? This is the average, everyone. But if I will ask change in length in my nail in 0.001 second, correct? If the interval of time is 0.001 second, I want change in length in my nail in 0.001 second. So this is what? This is the instantaneous, everyone. This is the differentiation, correct? So now we will write here change in length in my nail dl by dt equal to something we will get after simplification, correct? So here interval of time is getting very small. That's why it is what? It is the differentiation, everyone. In the differentiation, interval is very small, everyone, correct? No doubt. Let's see one more example, everyone. So what is happening in this example, everyone? Now I want to measure change in length in my pen. So now we are talking about the pen, everyone, correct? So we know that with respect to time, length of this pen is not changing, correct? If I will measure right now length of this pen and after 1 month, length will remain the same, correct? So length of this pen is not changing with respect to time. So here what should be differentiation of L with respect to time, everyone, correct? We know that with respect to time length is not changing. So it should be what? It should be 0, correct? Because here length of this pen is remaining same with respect to time, correct? So if something is not changing with respect to time, so differentiation of that quantity with respect to time should be what? It should be 0. So L is what, everyone? It is constant, but it is constant with respect to time. That's why if you will do a differentiation of this length with respect to time, then only we will get 0 here. So it is constant. So keep this thing in your mind, everyone. If we have something constant and we are doing differentiation of that constant quantity, then always we will get 0. Note down, everyone. Now we will discuss about the application of differentiation in the physics, everyone. So see it where we are using this differentiation in the physics. So first application is what? If you want to determine instantaneous velocity, correct? So instantaneous velocity can be written dx by dt. And if you want to find out instantaneous acceleration, can be written dv by dt. So here we are using differentiation, everyone, correct? And about this thing we will read in motion in the straight line chapter, everyone. There we will discuss about this. Now in the NLM chapter, Newton laws of motion, here we will discuss about the force. So force is equal to what? It is dp by dt, rate of change of momentum. So here again we are using differentiation, correct? And if you want to optimize, in the optimization also we are using differentiation. For example, it is used to determine the maximum height of the projectile motion and the minimum energy of the system, correct? Suppose I am throwing one object with some angle, correct? Like I have this pen and I am throwing this pen at theta angle. So it is doing projectile motion. So if I want to find out what the maximum height of this pen, correct? So this thing we can find out with the help of differentiation. And if I want to calculate minimum potential energy of the system and maximum potential energy of the system, here also we will use differentiation, everyone. So this is the application of differentiation in the physics. Note down, everyone. Now we will discuss about the rules for differentiation. So when we are doing differentiation, then we are following some rules, everyone. So here we have rule number 1. So what is the rule number 1, everyone? Derivative of constant. So the first rule of differentiation is that the derivative of every constant function is 0. So when we are doing differentiation of any constant function, then it is always 0. So so here we have one example also, everyone. Here we have c and we are doing differentiation of the c with respect to x. So c is what, everyone? It is constant. So we know that here c is the constant and it is not changing with respect to x, everyone. So when c is not changing with respect to x, so it should be 0, correct? So if you are doing differentiation of any constant function, then it is always 0. Now let's see one more example, everyone. Let's suppose I am doing differentiation of 2 with respect to x, dy by dx, and we are doing differentiation of 2, everyone. So 2 is what? The constant. It is not varying with respect to x, so it should be what? It should be 0. Now see one more example, everyone. If I will do a differentiation of pi value is 3.14, so it is fixed. This thing we know that. So now I am doing differentiation of pi with respect to x. So what it should be? Think it, everyone. What it should be? It should be 0, correct? Because pi is constant here. So if we are doing differentiation of any constant, then it is always 0. So here we have some example, everyone. dy by dx of 8, dy by dx of minus 1 by 2, dy by dx of root 3, correct? So 8 is what, everyone? It is constant, so it is 0. Minus 1 by 2 is also constant, so it is 0. And root 3 is also constant, so it is 0, correct? So here we are getting 0. So remember this rule number 1, everyone. If you are doing differentiation of any constant, then it is always 0. Note down, everyone. Let's see next rule, everyone. Rule number 2, power rule. So here we have x power n, correct? X is variable and this variable has n power. So if you want to do a differentiation of x power n, so after doing the differentiation, what we will get, everyone? Nx n minus 1, correct? So n is what? It is the power. So we are writing power in the front side, then we are writing x, and then we are subtracting minus 1 with this power, and then we are getting differentiation of x power n. So like this you have to remember it. So see it one example, everyone, then you will get clarity how it is working. dy by dx x power n, correct? So here I am taking x power 5. We want to do a differentiation of x power 5, everyone. So apply here power rule. So what we will get? 5 is what, everyone? It is the power, correct? So power we will write first of all front side. So 5x 5 minus 1. This thing we will get. So answer is what? It is 5x power 4. This is the answer, everyone. 5x power 4. Now see it one more example, everyone. Here we have dy by dx 1 by x. We want to do differentiation of this. So directly 1 by x differentiation we don't know, correct? So here we have to think, everyone, what we can do it here. So dy by dx 1 by x can be written as x power minus 1, correct? So x power minus 1. So now apply here power rule. So here n value is what? It is the minus 1. So now in next step, what I will do it here, power we will write in the front side. So minus 1 x minus 1, and we will subtract minus 1 with the power. So we have minus 1 minus 1 minus 2. So finally answer is what? Minus x, and power is minus 2. This is the answer for this question. So I hope this thing is clear, correct? How this power rule is working and how we can apply. Let's see next rule, everyone. Rule number 3, constant multiple rule. So here we have cu, everyone. So c is what? It is the constant. So according to rule, what we can do it, this constant we will put outside the differentiation, correct? This is the rule, everyone. So if constant is present with the variable or with some function, So constant put outside the differentiation, and we will do it differentiation of the remaining function. So this thing we will do it here. So here we have 3x square everyone. So 3 is what? It is the constant. So according to rule, what I will do it here, 3 I will put outside the differentiation. Now remaining we have x square, and then we will do differentiation of x square. So here we will use power rule. We know that xn power differentiation is what? It is n x n minus 1. So here we will get 3. So differentiation of x square is what? 2x 2 minus 1. So finally what we are getting? 6x everyone. So this is the answer for this question. So I hope this rule is clear. Note down everyone. Let's see next rule everyone. Rule number 4. So here we have n number of terms. You can see it u1, u2 and un. This all are present in summation. Correct? So according to rule, what we can do it here everyone, when we are doing differentiation, then we can do it separately differentiation. Correct? So separately we are doing differentiation of u1, then we are doing u2, correct, and un. So this thing we can do it. Now see it one example everyone, then you will get clarity how we can apply here. So here question is find the derivative of y x power 4 plus 12x, correct? So here x power 4 we have first term and 12x we have second term, correct? So term by term differentiation we are doing here. So let's see it how it is working. dy by dx. Now x by 4 we have first term. So separately I am doing differentiation of x power 4 plus dy by dx 12x, correct? So now if I will do it differentiation of x power 4, so it is what everyone? 4x 4 minus 1, so it is 3 plus 12. See it here, 12 is what? It is the constant everyone. So 12 we will put outside the differentiation, and differentiation of x with respect to x is what? It is the 1. So finally what we are getting? 4x cube plus 12. So this is the answer everyone, and this is the sum rule. If suppose we have subtraction in between this term, then also we can apply this rule here, correct? Individually we will do a differentiation of all the term and we will get the answer. So I hope this thing is clear. Note down everyone. Let's see rule number 5 everyone, product rule. So when we have two function and it is present in product and we want to do differentiation, then we will use here product rule everyone. So according to this rule, what we will do it here, this u is what? It is the first function everyone, and v is what? It is the second function. So first function we will write as it is first of all, and then we will do it differentiation of the second function. Plus sign we will put, then we will write second function as it is, and then we will do it differentiation of the first function. So this thing we will get everyone. And this is the product rule, and it is important everyone. So keep this rule in your mind. Now see it one example, then you will get clarity how we can apply on the numerical. So here we have find the derivative of y equal to x square plus 1 x cube plus 3. So this x square plus 1 is what? It is u everyone, and x cube plus 3 is what? It is the v here, correct? So see it what we will get, dy by dx, and according to rule, first of all u we will write as it is, means x square plus 1 we will write as it is, dy by dx, v is x cube plus 3. Then we will put positive sign, then we will put as it is, and then we will do differentiation of first function, means u, which is x square plus 1 here. So x square plus 1, and differentiation of x cube plus 3. Differentiation of x cube is 3x square, and 3 is constant everyone, so it is 0, plus x cube plus 3, and differentiation of x square is what everyone? It is 2x, and 1 is constant, that's why it is 0, correct? So this thing we are getting. After simplification we will get the final answer everyone. So like this we can apply product rule, correct? So I hope this thing is clear, everyone. Note down. Let's see next rule, everyone. Quotient rule. So when we have two function and this two function is present in the division and we want to do differentiation, then we will apply quotient rule, everyone. So according to this rule, what we will do it, first of all, we will write correct denominator function in the denominator and we will do it square here. Then this denominator function we will write as it is, correct, and then we will do a differentiation of the numerator function. Then put negative sign, then write down numerator function as it is and do it differentiation of the denominator function, correct. So according to this rule, everyone, we will arrange all things. Now see it one example, everyone, and this is important, everyone, so keep this formula in your mind. So let's see it one example. So you will get clarity here. Find the derivative of y equal to t square minus 1 t square plus 1. So t square minus 1 is what? It is u, everyone, and t square plus 1 is what? It is a v. And we want to do it here differentiation, correct? So what we can do it here, everyone? dy by dt equal to, correct, equal to, so here we want to do it differentiation. So what we will do it, denominator function we will write in the denominator and we will do it square here. So t square plus 1 whole square, and then denominator function we will write in numerator and we will write as it is. So t plus 1 we are writing as it is, dy by dt, correct, and numerator function we are writing and doing differentiation. So here u equal to what we have, it is t square minus 1. Then we will put negative sign, correct, then we will write t square minus 1 as it is, means u we are writing as it is, and then we are doing differentiation of v. So v we have t square plus 1. So first of all, what we are doing, we are arranging all things according to this formula. Now do it differentiation, everyone. So t square plus 1 we are writing as it is. Now we are doing differentiation of t square minus 1. So t square differentiation 2t and 1 is constant, that's why it is 0. So it is 2t, everyone, minus t square minus 1 and t square plus 1. Differentiation of t square plus 1 is what? It is 2t, correct. Now in denominator we have t square plus 1 whole square. So write down this thing as it is. Now here we have simplification part. Multiply 2t with this, everyone, and 2t with t square minus 1, correct, and after simplification you will get final answer. So like this you can do it, correct, differentiation, everyone, when we have two function in division. So this rule is known as quotient rule, everyone. Note down. Let's see next rule, everyone. Rule number 7, derivative of trigonometric function. So let's see it here, everyone. We have sin x. Sin x is the trigonometric function and differentiation of sin x is what? It is cos x. So keep this thing in your mind, everyone. If you have sin x, then differentiation is what? It is the cos x. So it is important, everyone. Now the next is what? If suppose we have cos x function. So if we will do differentiation of cos x function, then we will get minus sin x, correct. Now the next formula is what? If suppose we have tan x, then the differentiation of tan x is sec square x. Cotec x is minus cosec square x. If we have cosec x, then differentiation is minus cosec x cot x. And if we have sec x, everyone, then the differentiation of the sec x is sec x tan x. So this is the differentiation of the trigonometric function, everyone, and we have to keep in our mind. Now see it some example, everyone. So here we have example number A, y equal to x square minus sin x. We want to do a differentiation of this. So let's see it, what we will get. Here we have y equal to x square minus sin x, correct. So dy by dx, then we have x square first term and second term we have sin x. So here we are using correct sum rule, everyone. So right now in between these two terms we have subtraction sign here. So individual differentiation we are doing here according to the rule. So now the differentiation of x square is 2x, and here we have sin x. We know that differentiation of sin x is cos x. So we will get 2x minus cos x. This is dy by dx. Correct. Now see it b, everyone. B part, y equal to x square sin x. So think it, everyone, which rule we will use here. Which rule can be used here? So can I use here product rule, everyone? Because here we have two function x square sin x, and both are present in product here, correct? So here apply product rule, everyone, and according to product rule what we will get, dy by dx. So here we have two function x square sin x. So x square we are writing as it is, then we are doing differentiation of sin x, then put positive sign, then sin x we are writing as it is, then dy by dx x square. Now x square differentiation of sin x is what it is, cos x, everyone. Differentiation of sin x is what it is, cos x. So cos x plus sin x, and differentiation of x square is 2x. So this thing we are getting here after doing the differentiation. Now see it, C part, everyone. Here we have y equal to sin x by x. So here we want to do it differentiation of sin x by x. So here we have sin x and x both are in division. So can I use here quotient rule? Correct, because here we have two function and both are present in division. So can I use here quotient rule? So yes, correct. So this question I'm giving to you in a homework, everyone. Do it from yourself and apply here quotient rule. Then you will get answer. Now let's see one more question, everyone. Here we have y equal to 5x plus cos x. We want to do a differentiation here. We have 5x and cos x. In between this we have sum. So here I am using sum rule, correct? We have two terms, both are in sum. So individual differentiation we can do it here. So other rule will remain the same, everyone. So dy by dx, first of all I am writing differentiation of 5x. Then I will do it differentiation of cos x, everyone. So differentiation of 5x we are doing, 5 is constant, put outside the differentiation. Now here we have x, everyone, and differentiation of cos x is what it is, minus sin x, correct? This thing we knows already. So here I will write minus sin x. Now let's see next step, everyone. So differentiation of x with respect to x is what? It is 1. So here we will get 5. Differentiation of x with respect to x is what? Minus sin x. So finally we have 5 minus sin x. This is the answer, everyone. Alright, so note down, everyone. Let's see next rule, everyone. Rule number 8, derivative of logarithmic and exponential function. So log ex differentiation is what, everyone? It is 1 by x. And if you are doing differentiation of e power x, so it is again e power x. So keep this thing in your mind, everyone. If you are doing differentiation from log e x, then it is 1 by x, and e power x differentiation is e power x. So this thing we know now, and keep this thing in your mind. Now see it one example, everyone. Let's suppose we want to do a differentiation of log base e to x. So log x differentiation is what? 1 by x, but now we have log base e to x. We want to do a differentiation of this. So we want here dy by dx. So I'm doing differentiation this y with respect to x. Now we have log base e to x, correct? So log base e to x, if we are doing differentiation of log function, then we will get 1 by 2x, correct? Now we will do it differentiation of 2x, everyone. So differentiation of 2x is what? 2 is constant, correct? Put outside the differentiation, and differentiation of x with respect to x is what is the 1. So we will get here 2. So 2 will get cancelled out. So now here we have dy by dx equal to 1 by x, correct? So this is the answer, everyone. So if we are doing differentiation of log base ex, and if we are doing differentiation of log base e2x, we are getting same result. All right, note down, everyone. Now let's see it. Next thing, everyone, if suppose we want to do it differentiation of y equal to 2 power x, then what we will get? See it, one more example. If suppose we have function y equal to 2 power x, correct? Here 2 is constant and x is variable here, that's why it is exponential function. So here we have exponential function and we want dy by dx. So how we can do it differentiation right now? Think it, everyone. Correct. So we can do it one thing. If I will take log on both sides, so what we will get? So we will get, now I am taking log on both sides. So it is log base ey equal to log base e 2 power x, correct? This thing we have. So here we will use log property, everyone, correct? This 2 has x power. So we know that this property, everyone, if we have log base e x power y, so this power can be written in the front side. So this log base e x power y can be written as y log base e x. This thing can be written as, correct? So here x is what? It is the power, everyone. Write down this power in the front side. So now in the next step we have log base e y equal to x log base e2. This thing we have. Now do it differentiation, everyone, because we know that differentiation of log function 2 power x differentiation we don't know. That's why we are taking log on both sides, correct? So differentiation of log ey is what? It is 1 by y, and we are doing differentiation with respect to x here. So 1 by y dy by dx. First we are doing differentiation of log function, then it is 1 by y, then we are doing differentiation of y, then it is dy by dx. Now here log base e2 is constant, everyone. Put outside the differentiation, and here we have dx by dx. If we are doing differentiation of x with respect to x, then we will get 1. And put y on this side, so we have now dy by dx equal to y log base e2. This thing we are getting. Now let's see next step, everyone. So y value already we know that it is given in this question. It is 2 power x. So here we will write y equal to dy by dx equal to 2 power x log base e2. This thing we will get, and this is the final answer for this question, everyone. So if we have 2 power x, so result what we are getting, everyone, it is 2 power x log base e2, correct? So when we have this type of exponential function, so take on both sides log, everyone, and do it differentiation and follow log property also. So like this you can do it differentiation. See it one more example, everyone, then you will get more clarity. Okay, see it, everyone, one more example. Suppose we have y equal to e power ax. This thing is given, y equal to e power x. So we want here dy by dx, everyone. So what we will do it here, we have y equal to e power ax and we want dy by dx. So here what we can do it, first of all take log on both sides. So we have log base e y equal to log base e power ax, correct? So this e has a power x, correct? So here we will use log property. So now we have ax log base ee. So see it, everyone, and keep this thing in your mind. If base and value both are equal, e is what? Is the base, everyone, e is the value, So if base and value both are equal, so definitely exponent should be 1. Then only it is possible. This thing we knows already from the logarithm. So here base and value both are equal. That's why it should be 1. Like we have log base b and the value is b. Then again it is 1 everyone. So here log base e we have, so it is 1 everyone. So we will get here log base ey equal to a power x. Now do it differentiation everyone with respect to x. So we will get 1 by y dy by dx, and a is constant, put outside the differentiation, dx by dx, and differentiation of x with respect to x is what? It is the 1. So we have here dy by dx equal to ay. And what is the value of y everyone? It is e power ax. So here dy by dx equal to y is what? It is e power ax, correct? So it is a e power ax. This thing we will get. So this is the final result everyone, and this is the answer also. So if we have e power ax, then what we are getting everyone? We are getting a e raised to ax, correct? Means whatever here we have constant, that constant is coming in the multiply, correct? So analysis is important here everyone. So when we have e power ax, then differentiation we are getting a e raised to ax. If suppose we have in the question y equal to e power 2x and we want to do a differentiation of this. So here 2 is what? It is a constant everyone. So differentiation of this e power 2x can be written as dy by dx equal to 2 e raised to 2x. So whatever constant we have with this variable, that constant we will write in the multiply. So no need to take log and no need to do it this long procedure everyone. Directly you can write down the answer. If you knows this thing, correct? If you keep this thing in your mind, so directly you can write answer everyone. So note down everyone. Let's see next rule everyone. Rule number 9, power chain rule. So if any function has some power, then we will apply this rule everyone. So here u is what? It is the function, and this function has n power. So first of all, we will do it differentiation of the power everyone, then it is n u n minus 1, and then we will do it differentiation of this function, which is du by dx. So note down everyone how we can do it if function has some power. How we can do a differentiation when function has some power. So now see some example everyone, then you will get more clarity, correct? So here we have sine power 5x and we want to do a differentiation of this. So what we will get, let's see it. We want to do a differentiation of sine power 5x. So sine x is what? It is the function everyone. So sine x is what? It is the function. So it is u here. So now next thing is what? Dy by dx. Sine x we will replace with the u everyone. So u power 5 we have, correct? So first of all, we will do a differentiation of the power. So it is 5 u 5 minus 1. So it is 4. Now do a differentiation of u. So this is du by dx. Now in the next step, what we will do it, we will put value of u. So 5 u is sine x everyone. So sine 4x and the differentiation of u with respect to x. So du by dx is what everyone? Means u is what? It is the sine x. So I am replacing u with the sine x. So now we are doing differentiation of sine x. Tell me what is the differentiation of sine x everyone? Think it what it is. If you will think differentiation of sine x is what? It is the cos x. So can I write here 5 sine power 4 x and differentiation of sine x is what? It is the cos x. So this is the final answer everyone. Correct? So if function has some power and we want to do differentiation, then we will apply power chain rule. Let's see one more example everyone, then you will get more clarity. So here we have 2x plus 1 power minus 3. So this 2x plus 1 is what? It is the u everyone. So this function has power minus 3. So how we will use this? Let's see it everyone. So first of all, we will do it differentiation of the power, everyone. So if I will do differentiation of the power, so it is what? Minus 3, 2x plus 1 plus 1, and now minus 3 minus 1. Correct? And then do a differentiation of this function, which is 2x plus 1. So in the next step, we will write dy by dx 2x plus 1. Correct? So let's see it next step, everyone. Minus 3 2x plus 1. Minus 3 minus 1 is what? It is a minus 4, everyone. And the differentiation of 2x plus 1 is what? It is 2. Correct? So this thing we will get. So differentiation of 2x plus 1 is what? It is only just 2, because 2 is constant put outside the differentiation. X differentiation with respect to x is 1, and 1 is constant, and differentiation of the constant is 0. So finally what we have, everyone? Minus 3 into 2, it is minus 6. 2x plus 1 power minus 4. This thing we are getting, and this is the final answer. So I hope this thing is clear. Now see it one more example, everyone. So here we want to do a differentiation of 1 by 3x minus 2. So how we can do it, everyone? This 1 by 3x minus 2. Correct? So can I write this thing 3x minus 2 power minus 1? Correct? Can I write 1 by 3x minus 2 in the inverse form? So it is 3x minus 2 power minus 1. Correct? So now here we have algebraic function. You can see it here. Here also we have. So do a differentiation of this. So here we will apply again power chain rule. First of all, we will do differentiation of the power, everyone. So it is minus 1, 3x minus 2 minus 1 minus 1 minus 2, and then do a differentiation of 3x minus 2. Correct? 3 is constant. Differentiation of x with respect to x is 1, everyone. So it is 3, and differentiation of 2 is 0. So it is 3, everyone, only. So differentiation of 3x minus 2 is what? It is just 3. So finally we have minus 3, 3x minus 2 power minus 2. This thing we are getting, and this is the final answer for this. So when function has some power and we want to do a differentiation, correct, then we will apply power chain rule. Note down, everyone. Now see, let's see next slide, everyone. Practice problem. So here we have some practice problems, and this all practice problem I am giving to you in a homework, everyone. So do it from yourself. Like we have ax plus b power n. So use your power chain rule, correct? Then you will get, then we have sin ax plus b. So do it first of all differentiation of sine function, then do it differentiation of ax plus b, then you will get the answer. So this is your homework question, everyone. Note down. Let's see next topic, everyone, double differentiation. So first of all, we will see it how we will represent double differentiation in different notation. So mostly we are using Leibniz notation, everyone. So see it, Leibniz notation. Let's suppose we have y function and we want to write down first derivative of y, correct? So it is dy by dx. So this is the first derivative of y in the Leibniz notation, everyone, dy by dx. If I will write double differentiation of y in Leibniz notation, so it is d2y by dx square. Correct? Now let's suppose again we have y function and now we want to use it here Lagrange notation. Correct? So if I will use Lagrange notation, everyone, so if I'm writing first derivative of y, so it is y prime, and if I will write second derivative of y, so it is y double prime. So this is the Lagrange notation, everyone. If suppose we have fx function and we want to write down first derivative of fx in Lagrange notation, so this is f prime of x. How we will read this, everyone? F test x, f prime of x. And if I will write double differentiation of this fx, so it is f double prime of x. So this is the Lagrange notation, everyone. So like this we can represent this double differentiation. So note down, everyone. Let's see this question, everyone. So the position of the particle is given by the equation as equal to ft equal to tq minus 6t square plus 90, where t is in measure in the second, s in the meter. Find the acceleration at time t. What is the acceleration at 4 seconds? So in this question, we have position equation, everyone, as a function of time. Here position is changing, correct, with respect to time, everyone. So it is tq minus 6t square plus 9, and we want a acceleration, correct. So if we will do it first time differentiation, then we will get velocity, correct. So if I will write here velocity as a function of time, so it is what it is, ds by dt. So this is the first derivative. So here we have tq. So differentiation of tq is what it is, 3t square, and differentiation of minus 6t square is what, everyone? Minus 6 is constant, put outside the differentiation, and differentiation of t square is 2t. So it is minus 12t, and differentiation of plus 90 is what it is, plus 9 only. So this is the first derivative, and if we are doing first derivative of position, then we are getting velocity. Here we want a acceleration, so we need to do it here again, differentiation, everyone. Then we will get acceleration as a function of time, correct. So the second differentiation of t square is what? It is 2t. So 3 into 2t is 6t, and minus 12t differentiation is minus 12, and 9 is constant, differentiation of 9 is 0. So acceleration as a function of time we are getting here, everyone, at equal to 60 minus 12, correct. This is the acceleration at any t time. Now here we want acceleration at 4 seconds also, correct. We want acceleration of this particle at 4 seconds. So here we want at t equal to 4 seconds. So what we need to do it here, everyone, we will replace this t with the 4. So acceleration at 4 seconds can be written as 6, t value is 4 here, minus 12. So 24 minus 12, it is 12 meter per second square. This is the acceleration at 4 seconds. If you want acceleration at 3 seconds, then we will replace t with the 3, everyone, correct. And if you want at a 5, so we will replace t with the 5. So at that time we will get acceleration. So this is the double differentiation, everyone. It is very easy. Do it differentiation first time, and whatever you will get, do it again. Then you will get double differentiation, correct? Note down. Let's see next topic, everyone, maxima and minima. So first of all, we will discuss about the maxima. So for the maximum, what is happening, everyone? As x increases, the slope is decreases. So if x is increases, then slope is decreases. So what is the sense of this line, everyone? Let's see it. Let's see this graph. Then you will get clarity what he is saying here. So let's suppose here we have x versus y graph. So this is x-axis and this is y-axis. And this type of curve we have. This is 0, 0, correct? So let's suppose I want slope at this point. So what I will do it, I will draw one tangent here and see it how much angle it is making with the horizontal. So let's suppose this angle is theta 1, everyone. Now if I want slope at this point, so draw again here one tangent and look at how much angle it is making with the horizontal. So this angle is what? It is theta 2. Now look at this point, draw one tangent, and this is theta 3. So you can see it here, theta 3 is 0, everyone, because now it is parallel to the horizontal axis. So theta 3 is 0 here. So if you look here, everyone, if you are moving in this x direction, means if x is increasing, then what is happening with the slope? If x is increasing, then you can see it here, slope is continuously decreasing because tangent is rotating in clockwise direction, correct? So if x is increasing, then slope is decreasing here. dy by dx is what? It is the slope, everyone, and we are writing m also sometime, and it can be written as tan theta also. So tan theta dy by dx, these all are the slope, everyone. So we can see it here. If x is increasing, then slope is decreasing here. So this is the required condition for the maxima. Correct? Maxima is forming at this point, everyone. This is the maxima value of this function. And you can see it here at this point, slope is 0. So here maxima is forming, then slope is what? It is a 0, and rate of change of slope is what? It is the negative, because it is decreasing. So this is the two required condition for the maxima, everyone. The first condition is what? When the maxima is forming, then slope is 0 at that point. The second is what? Rate of change of slope should be negative. So keep these two conditions in your mind, everyone. So I hope this thing is clear how we can determine maxima. Slope should be 0 at that point, and rate of change of slope should be negative. Let's see next topic, everyone. Minima. So for the minima, what is the required condition? For minima, as x increases, slope is increases, everyone. So here if x is increasing, then slope is increasing. So let's see it here, one graph, everyone, then you will get clarity what is happening here. So this is x-axis and this is y-axis and this is 0, 0. And let's suppose we have this type of curve here. In this xy plane, we have this type of curve. Correct. So we want to see it here. Here minima is forming or maxima is forming in this curve. So first of all, I will draw here one tangent, everyone, and I will measure what is this angle here. So this angle is what? It is the theta 1. Now I will draw tangent at here and I will see it what is the angle made by this tangent with the horizontal. So this is theta 2. And now I will draw tangent at here and this is theta 3, everyone. So here what is happening? When x is increasing, when we are moving in the x direction, then continuously this theta is increasing, everyone. If theta is increasing, then slope is increasing. If theta is increasing, then tan theta will increase, and if tan theta is increasing, then slope is increasing, because tan theta is what? It is the slope, everyone, and it is equal to dy by dx also. So here what is happening? If x is increasing, then slope is increasing, correct? And at the third point, what is the slope, everyone? Dy by dx, it is 0. Slope is 0 here, everyone. So here slope is 0, then here minima is forming, correct? So here minima is forming. So for the minima, we have two conditions, everyone. Condition for the minima is what? Slope at that point is 0, and rate of change of slope is what? It should be greater than 0, everyone. Means it should be positive. Here we know that here rate of change of slope is what? It is positive. It is increasing continuously if x is increasing, correct? That's why it should be greater than to 0. And in the maxima, what is happening when the maxima is forming? Then rate of change of slope is what? It is negative, everyone, correct? Then rate of change of slope is negative, because here slope is decreasing. That's why it is happening. So this is the required condition for the maxima and minima. Keep this thing in your mind, everyone. Now let's see one example on the basis of this maxima minima concept, everyone. So question is given here is particle position as a function of time is given as x equal to 5t square minus 90 plus 3. Find out the maximum and minimum value of the position coordinate. Also plot the graph. So here we want position coordinate for maxima and minima, everyone. So let's see how we can do it this question. So here function we have x equal to 5t square minus 90 plus 3, correct? This function is given. So here position is the function of time, correct? And we want here maxima and minima coordinate. So what we will do it, first of all, we will differentiate this x with respect to time. So what we will get, everyone? 5 is constant, differentiation of t square is 2t, so it is 10t. 9 is constant, minus 9 is constant, differentiation of t is 1, so it is minus 9. And 3 is constant, everyone, differentiation of 3 is 0. So finally we are getting 10t minus 9, correct, dx by dt. So this is what everyone, it is the slope, correct, this is the slope. So we know that if maxima and minima is forming, then at that point slope should be 0, correct. So we are looking for the coordinate maxima and minima, so slope should be 0, so I will put dx by dt equal to 0. Now we have 10t minus 9, correct. So from here we will get t value, and t is equal to how much everyone, it is 0.9 second. So if we will simplify this, then what we will get here 0.9 second everyone, correct. So at this time maxima or minima is forming, we don't know right now, correct, here maxima forming or minima forming. For this we need to find out your rate of change of slope. So for this again I will do differentiation. So do it second time differentiation everyone, d2x by dt square equal to, so we have here 10t minus 9, so differential of 10t is what, it is 10, and 9 is constant, so it is 0. So second differentiation we are getting 10 here, and 10 is positive everyone, means rate of change of slope we are getting positive here. d2x by dt square is what, it is the rate of change of slope, and rate of change of slope we are getting positive, and we know that when rate of change of slope is positive, then we have minima everyone, because for the minima required condition is what, rate of change of slope is positive, means d2x by dt square should be greater than to 0. This is the condition for the minima. So now this thing is confirmed, here minima is forming, and the coordinate of the minima is what, it is 0.9 second, it is the t. We will find here x also everyone. So for the x, what we can do it here, put t value in this function everyone. So we have x equal to 5t square minus 90 plus 3. So here time we are putting 0.9 second. So let's see what is the position of the particle at 0.9 second. So 5, t value is 0.9 second. So do it here square, minus 9, t value is 0.9 plus 3. And now simplify this. So after simplification, you will get x equal to minus 1.05. Correct? This thing you will get. So this is the position of the particle. Correct? So at 0.9 second, particle is present at minus 1.05, and at this place minima is forming. Correct? All right. So coordinate of minima we got it. Now we want to plot here graph also. So for the graph we have required some coordinate everyone. So many coordinate we have required, then we will get proper graph. So let's see it, what we can do it here. So now we want to plot the graph here. Okay, so this is time axis, this is x everyone, positive x, and this is negative x, and this is 0 comma 0. Correct? First of all, we will see it here from where this graph is starting. So I will put here t equal to 0. So if I will put in this function t equal to 0, then see it what we will get. So if I am putting t equal to 0, then what is the value of x everyone? So x equal to, we have 5t square. So 5t square 0 plus 3t minus 90. So now here we have minus 90, t is 0, and then plus 3. Correct? This thing we have. So if I am putting in this equation t equal to 0, then what we are getting everyone, x equal to, we are getting 3. So when I am putting here t equal to 0 in this function, then x equal to, we are getting 3. Means from this position this graph is starting everyone. This thing is clear now. So it is starting from here. Now what I will do it here. This is 1, this is 2, and this is 3. This is 1, 2, and 3, and 4. Correct? Graph is starting from where? It is starting from the here. So this is t is what it is, 0 everyone, and x is 3. So this is the coordinate of this point, 0 comma 3. and from here this graph is starting, and this graph go up to infinite everyone, because if I will put here t equal to infinite, then x equal to infinite we are getting, and we know that time is always increasing, correct? So here time is always increasing, that's why x will go till infinite. So this graph is going up to infinite everyone. Now the next thing is what, if I will see it here, coordinate of minima. So this is what everyone, it is 1 and this is -1, and coordinate of the minima is what, -1.05 and t equal to 0.9. So it should be here everyone, it should be here. This is the position of the minima. Here minima is forming, and coordinate is what it is, t we have 0.9 and x is -1.05. all right, now next what we can do it here, we will put in this function x equal to 0. So if I will put x equal to 0, then we will get two value of t, correct? Here we have x, we are putting x equal to 0. So now we have 0 equal to 5t square minus 9t plus 3. This equation we have, correct? So if I will put x equal to 0, then we are getting two value of t, correct? So if you want to simplify this equation, then we need to use a Sridharacharya formula. So here a equal to what it is 5, b equal to -9, and c equal to what it is 3 everyone. So a equal to 5, b equal to -9, c equal to 3. Now use Sridharacharya formula, then you will get two value of t. So equal to minus b plus minus under root b square minus 4ac by 2a. Now put all value in this formula. So what is the value of b everyone? It is -9, minus is plus, so 9 plus minus b is 9, so it is 81, minus 4, a is 5, c is 3, divided by 2a. So what is the value of 8 is 5. So now simplify this, then you will get two t values. So after simplification, correct, what you will get everyone? I think we will get 1.36. After simplification, you will get t equal to 1.36, and second value you will get 0.44, correct? This thing you will get after simplification. So when x equal to 0, then t equal to 1.36 and 0.44 seconds. So two times we are getting x equal to 0 everyone. So when I will plot the graph, so this graph will look like this everyone. It is starting from here. So if I will mention 0.44 seconds, so it is here everyone. And now next point is what we have. It is 1.36. So 1.36 is here. So now let's see what type of graph we have. It is starting from the here. And it is going till infinite everyone. So this is rough diagram. It is not an exact graph, because if you want to plot the exact graph, then you have required more coordinates. But roughly we will get this type of graph everyone, and it is going up to infinite. All right. So right now this thing is clear, how we can plot the graph, correct, and how we can determine maxima and minima. Note down everyone.